Okay, so what we're going to be doing here is to see exactly how to do one of these things called a Punnet square. Now, Punnet squares are really useful tools for doing genetics problems, and I want to just go through the mechanics of how to do one of these Punnet squares, just in case you've never done one of these before. So first of all, let me show you what a Punnet square looks like. Before I start getting into this video too much, just as a reminder, I've put a handout of Punnet squares online on the resources page. You should really have a copy of that printed out while we're going through this, so you can write this down for yourself. And also that handout's going to come really handy as you go through the rest of this module. Because what you're going to do is you're going to see a lot of different genetics problems and questions that I'm going to ask you. And while I will give you the answers to those questions and how to get to those answers, I really want you to try to do these problems yourself. So, you see the problem, you have the Punnet square, try it yourself, and then, take a look and see what my solutions are. If you just read the solutions, you're not really going to be fully learning, how to use these Punnet squares to analyze genetic problems. Anyway, here's a Punnet square, here's how to do it. Everyone has their own little ways of doing it. This is my way. The first thing I like to do is I like to know what the genotypes of the parents are. Basically, before you even start the Punnet square, what I want to do is on the left side of the Punnet square, write down the genotype of the male, whatever that is. Now, let's say, for example, the male's genotype is the heterozygous genotype. Well, what's the genotype of someone who's heterozygous? Well, you should know. It should be something like big A, little a. Person has a heterozygous genotype, both alleles are different. Up on top, I like to write the female's genotype. And let's say the female has the genotype of the homozygous recessive genotype. You should know homozygous recessive genotype is something like little a, little a. All right, we haven't even started the Punnet square yet. This is just off to the side. And the way I feel it is that if you have good starting materials, if you know what you're starting with, it's going to be less likely that you're going to make a mistake doing one of these Punnet squares. Okay, so now that we know what the genotypes of the parents are, we really don't care about them so much as we care about their gametes. Sperm cells for the male, egg cell for the female. Now, if the male has the genotype big A, little a, what are the possibilities for the sperm cells? Well, half of the sperm cells will have the big A allele, half of the sperm cells will have a little a allele. So we write those two possible genotypes for sperm cells in those open boxes on the left side of the Punnet square. Now, if you're not sure what to put in these open boxes, it's really simple. If you had the genotype of the male written out here, all you do is you take the first allele, put it in the first box, take the second allele, put it in the second box, and you're done. That's it. That's the little shortcut. For females, it's the same thing. Her genotype is little a, so put a little a in the first spot, little a in the second spot. Of course, her egg cells can only have one copy of the little a allele. So now that we know what the possible genotypes are of his sperm cells and the possible genotypes of her egg cells, what we want to know is what are the possible genotypes of their children. And the way to do this is to say, what if one sperm cell fertilized one egg cell? So, if this sperm cell that has the big A allele fertilized this egg cell that has the little a allele, what we do in this upper left-hand box is to write the allele of the sperm cell and then the allele of the egg cell. If that sperm fertilizes that egg, the child that results from that fertilization is going to have the genotype big A, little a. Now, just as a reminder again, when you're writing out heterozygous genotypes like big A, little a, you always write the dominant allele first and then the recessive allele. So it's always big A, little a. You never see it as little a, big A. For the upper right-hand corner, it's the same thing. Sperm cell giving a big A allele, other egg cell giving the little a allele. That child would have the genotype big A, little a also. For this box in the lower left-hand corner, the genotype of the child would be little a, one little a from dad, the other little a from mom, and lastly, what goes in the bottom right-hand box? Hopefully you just said little a also. One little a from dad, one little a from mom. So in this 2x2 grid here in this Punnett square, those are the possible outcomes for what their children might be. You know, every time you have a child here, basically what this Punnett square is saying, every time they have a kid, half of the time their kid will have the genotype big A little a, half the time the kid will have the genotype little a. Now, what does this mean? Is, one genotype good or bad? Well, that depends on the situation, and as we go through lots of different examples of genetics and lots of different examples of Punnett squares, we'll see, which genotypes are good and which genotypes are bad and which genotypes lead to diseases and things like that. But I wanted to do here is to show you the absolute mechanics of how these Punnett squares work. Over the rest of this module, we're going to see more of an explanation of what these Punnett squares actually mean. I'm done.